Hello, my dear serious students. Your favorite teacher, Durga Shankar sir, welcomes you. Now, today is the part 5 of the lesson height and distance. Part 5. Now, part 1, it was the introduction, all the 16 problems in NCERT textbook, exercise 9, are divided into total 7 types according to the diagrams. You can go through the part 1, my video part 1, you can come to know how we are divided. In part 2, the type 1, the 7 types, the type 1 was discussed in part 2. Question 1, question 2, 3, 4 and 5, they are coming in part 1 type, type 1 type. Type 1 is single right angle triangle. All the question, you go through, watch the video, you can come to know why I have taken all the 5 problems together. Then in part 3 of this video, question number 6, 11, 13, 15 and 16 are discussed. Here, two right angle triangles on a horizontal line. Okay, watch my video part 3, you can come to know, and all the 5 problems discussed together so that you can make a link, and it will make you so many comfortable that how to recognize and how to remember all the 5 problems. They are not different from each other. They are actually essentially same because diagram is same. In part 4, question number 7, 8 and 9. 7, 8, again same type of problem because this I have taken type 3. Type 3 is the combination of two right angle triangle and on vertical line. This question 7 and 8. Question 9, combination of two right angle triangle. One height is smaller, another height is taller, and the horizontal line is same. Okay. Now, in part 5, today we will conclude the chapter. Last part, part 5, is the type 5. Type 5 is question 10. Here, both the horizontal line are same distance, both the vertical line are same distance, and in between a horizontal line, and but horizontal distance are different in the point in between the horizontal line. This is the type 5. In type 6, the horizontal line is same for two right angle triangle. Horizontal line is same, but vertical line, one is smaller and one is taller. And here special thing is from the smaller horizontal line, from the top, once we are looking at the top of the taller horizontal vertical line and bottom of the vertical line. These are special types. And the 14, question number 14 is the type 7. Here horizontal line is different but vertical line is same. Here one balloon is flying or aeroplane is flying. This kind of question, this kind of figure coming. Okay, so to get the complete idea of my concept of teaching, please go through or watch the all the videos, that is part 1, part 2, part 3, part 4 and today's part 5, and you can get the complete idea. Okay, so let us start today part 5. Question number 10. Question number 10 is talking about two poles of identical height on either side of a road. Either side of a road, two poles of identical height, and one man is standing in between somewhere in the road, and the road total distance is 80 meters. Total distance is 80 meter. Okay? And when from this point, suppose the pole is AB, CD, height is same, both the heights suppose HH. And when from this point, so suppose this point is E, from point E, when looking at the top of the C, the angle is 60 degree. Closer is 60 degree, and top of the A, this angle is 30 degree. Okay? Now you have to find out the height. The height you have to find out. Okay? Now, very simple. If you from here to here you take the x meter, and from here to here you take it as a y meter, and definitely x plus y, finally it will come 80 meter. Okay, 80 meter. Now, take two triangle, one triangle in triangle ABE, triangle ABE. Triangle ABE, this is 90 degree, this is 30 degree, this is opposite, this is adjacent. So, tan 30 degree is equal to AB upon BE. AB upon BE. Okay. Now tan 30 is 1 upon root 3, and AB is H, BE is X. So X equal to H root 3. Okay. Now here another triangle, in triangle CED, tan 60 degree, equal to CD upon DE. Now CD is H and D is Y, and tan 60 degree is root 3. So root 3 is equal to H upon Y. So Y is equal to H upon root 3. Okay. So finally x plus y equal to 80. So x you put H root 3, and this you put H upon root 3. Okay. So this is equal to 80. Now if LCM will come, LCM, root 3 is the LCM, and it will root 3, 3h plus h is equal to 80. Okay? 3h plus h equal to 80. So 4h, from here to here, that has come. 4h upon root 3 is equal to 80. The h is equal to 80 into root 3 upon 4. That means h is equal to 20 root 3. This is the height of the pole. The height of the pole. And x, what is x distance? X is equal to h value is 20 root 3 into 20 root 3 into root 3. So 20 into 3, that means 60 meters. This is the distance, and here y is equal to h root 3, means 20 root 3 upon root 3, means y is equal to 20 meters. Okay, so one distance is 60 meters from here to here. It is 60 meters, from here to there 20 meters, and each height is 20 root 3 meters. Understood? Very simple. We take consider the triangle, right angle triangle. 12. One 7-meter high building on a ground. There is a tower. one man watching bottom of the tower, that is depression. This is the horizontal line. Every angle, whether it is angle of elevation or angle of depression, we should consider from horizontal line only. And when looking at the top of the tower, angle of elevation is 60 degree. And when it's the bottom of the tower, angle of depression is 45 degree. Now, this is a right alternate angle, Z shape alternate angle. So this one 45 degrees, so this is also 45 degree. Alternate angle. That's why this is also 45 degree. Now consider this A, B, C, D. Okay, and this distance, suppose this distance is H. Now, here coming, this is this is the 7 meter. The 7 meter we will take afterwards at the end. Okay, I taught you that all this calculation value you can take at the end. Now here, in triangle, always try to find out right angle triangle. This is also made up of two right angle triangles. One is ABD, another is A, suppose consider this point E, AEC. This is the right angle. Now in triangle ABD, here tan 45 degree is equal to the height, that opposite side upon hypotenuse. The opposite is AB, opposite upon adjacent. Adjacent is BD. Okay, so tan 45 1. Now AB is 7, BD is X. So X is equal to 7 meter. So this AE also will be 7 meter. Okay, that means BD is equal to 7 meter, and this is also equal to AE. This 7 meter height AE, this will be useful here in this triangle. Now in triangle AEC, tan 60 degree. Tan 60 degree equal to opposite upon hypotenuse, means AE upon not AE, CE upon AE. Okay, now CE, that we don't know. So CE we take CE only, and AE is 7. Tan 60 degree is √3. So CE upon 7 equal to √3, therefore CE is equal to 7 √3. So height of the tower, what is the tower? Tower is CD. So CD is equal to CE plus ED. And what is CE? CE is 7 √3. And what is ED? ED is 7 meter. The 7 meter, they equal 7 meter. So if we take 7 common, so √3 plus 1. This is the answer. √3 plus 7 plus 1 meter. Follow? Is a one kind of problem you can say. Horizontal road, on the horizontal road, and here on balloon. Or sometimes question may come on aeroplane. Something is flying, okay, in the sky, and you have to find out the height told, the distance you have to find out, distance told height you have to find out. And here total height given 88.2 meter, and one girl is watching, the girl is 1.2 meter height. So our calculation of interest, the height of interest is 87 meter. So we consider 87 meter, minusing the height of the girl. Now, when the girl is standing here, when balloon was here, this position, suppose position AB, that time the angle of elevation was 30 degree. And when balloon comes closer to the girl, and that new position is suppose A dash B dash, new position is A dash B dash, that time angle of elevation becomes 60 degree. Now we have to find out the distance between B, B dash. This we have to find out. Very simple question. Okay. Now, for generalize the question, this height I consider is h. Okay. And this distance, the first distance, as I told you, the longer distance we consider as x, longer distance as x, and the shorter distance we consider y. Okay. Now what is b, b dash? B, b dash simply x minus y. So first find out x, then find out y, then minus them, and get the b, b dash. Very simple way you can find out. Now, why I am taking the whole as a complete distance? Because we have to consider the whole triangle. So it is to simplify, take on single distance. Now in triangle A and this watching point, suppose this watching point is C. Okay. Now ACB, in triangle ACB, the girl is watching here, ACB. Okay, and this effective height I am considering, not taking the girl's eyesight, okay, from eyesight on. And this complication I just remove it. From the beginning, you remove the complication. And ACB, tan 30 degree. Tan 30 degree will be equal to h upon x. Simply I just put the value, h upon x. So tan 30 degree is 1 upon root 3 equal to h upon x. So x equal to h root 3. Okay. Now in triangle A dash C B dash. A dash C B dash. Okay, A dash C B dash. What is there? A dash C B dash. That is tan 60 degree. Tan 60 degree equal to, here again it is h upon y. Okay, and tan 60 is root 3 is equal to h upon y, and here y is equal to h upon root 3. So, we are interested to find out b b dash. So, b b dash equal to x minus y. X minus y means h root 3 minus h upon root 3. That is 2h upon root 3. 2h upon root 3 means it is 2h root 3 upon 3 by rationalizing. Multiply by root 3, multiply by 3. Now here finally put the value of h. Okay, so that this distance between the two positions of the balloon is 2 into h value is 87 root 3 upon 3. This you cut 29 to the 58 root 3. Okay, the final question is balloon during the distance travel. The distance travel. Distance travel by the balloon is equal to 58 root 3 meter. Okay, here we end our chapter and hope you all followed, understood, enjoyed. Still, if you have some doubt, please ask me in your comment box. I definitely answer you. Thank you.